Hi and welcome. We continue to talk about Ansys, and today we talk about Ansys Workbench introduction course, and we on a second part we will talk about analysis system. It's a main type of tools that you use with Ansys Workbench, and we have different type of calculation. So we will talk about this one. And as we say in previous video, all our tools that we can use in Ansys Workbench that we use for create project schematic, project pipeline, and pipeline of design process, your workflow, and so on. So all objects contained in Toolbox. In Toolbox we have a couple collections. Analysis system, it's most useful for most of users. Component system and some others. So when you select something in analysis system, for example static structural, it creates object in Workbench project schematics, and firstly it say the name of type of this object. Then we have some points, some stages, some sub-objects which can be found on component system. For example, here is engineering data. This is geometry. This is mechanical model, and so on. So, analysis system, it's a big object for solving one type of computational tasks, and those computational tasks and those objects created from different product, from different objects from component systems. This is how analysis systems look like on my computer. This is a full list of all objects from analysis system. Some of them white, some of them brown or orange, something like that. I have problem with colors, so sorry if I don't correct with name. But my thoughts it's not so important. More important that those lists for your answers could be different. It depends on your type of license, and some of them will present on your computer and some will absent. So I doesn't have Ansys Motion, I doesn't have iSync, I doesn't have Blade Gen and Speos, so I doesn't have not only license but those products in those list. Okay, this list from A to Z, but we will talk about it later. And much more important that if you look here, different type of objects have different icon types with different color. Some of them green, some of them blue, purple, and so on. This is different type of calculations. But before we talk about different type of calculation objects, we need to talk about our solution objects. So, as we said previously, A, it's a name of object. It's number of object. Static structural, it's a name of type of object. It can be static structural, it can be thermal transient, it can be any type of object from analysis system and any type of object from custom system. The next one is a different stage, and for example for static structural we have engineering data, it open another window, as we see. Geometry, it can open different type of window, a different type of application. And for mechanical tasks, model, setup, solution, and result will open one application, Ansys Mechanical. For other type of calculation, for example, for fluid flow, model, setup, solution, and result can open very different objects. For example, for CFX, mesh model would be created with Ansys Mechanical. Setup will open Ansys CFX preprocessor. Result will open Ansys CFX postprocessor. And solution will open Ansys CFX solver. For Fluent, mechanical model can be opened in Ansys Mechanical or in Fluent meshing, depending on what type of object you will use. Setup, solution, and result will open Fluent with new interface. So there are some differences, and we show some additional objects. Okay, with those triangle or by right mouse button, we can open context menu, which can help us to do something. For example, we can refresh all information with project schematic. We can update, and this update button will update only those objects and those stages that you choose. If you choose static structural, you will update full object. If you choose some stage, you will update only this stage. If you click right mouse button on a project, not on object, you will update whole project. You can duplicate any object on project schematic. You can export them, you can replace it with different type of analysis, you can clear data that was generated by computer, not by you, by computer. So, for example, you create all this stage, you work with all this stage, you solve your task, you have result, and you can clear those results or clear mesh. Mesh and result created in automated view by Ansys with some your efforts, but in semi-automatic regimes. So clear generated data, clear those semi-automatic created data. Also, you can rename some object, delete some object. You can close all application. You can open directory of this object. You can add some node and many other things. We will talk about this right mouse button later when we return to our Ansys Workbench in the end of this course. So, engineering data, open the tab of engineering data, so it's materials. It's called engineering data because in early version of Ansys Workbench, second version, Ansys Workbench second release, it's from Ansys 12. Ansys thinks that all engineering data, not only materials, would be here in engineering data. But during growth of version, this stage stay only with material data, and for adding different type of engineering data, other engineering data, Ansys create additional objects that called external data. So we will talk about external data later, and today we will talk about engineering data. As we say in previous video, we can create materials here. We can choose some material from engineering data sources. We can change those materials. We can add from this collection any type of properties, mechanical properties, and do some exports of those materials and so on. Something like that. With this geometry, you can open some application. For example, here we see Ansys Design Modeler. And this is Ansys Mechanical. And this Ansys Mechanical would be open from model, from setup, from solution, and from results. For structural tasks, static structural, model, linear backlink, transient, explicit, and so on, all this stage will open Ansys Mechanical. And that's very important because those Ansys Mechanical can be very different. You can see it in a different manner. For example, here, mesh object, so it's a stage of mechanical model. Here, the stage which called static structural here, and this is setup stage here. And as you see, it has some difference in type of view. If we go further, for example, to solution, it can look like this or like this, for example. And if we came for result, it can look something like that. But all those views, it's a different regime of Ansys mechanical application. We work in a one window with one application. It's very important. So, for example, you see that this one look much closer to this one, but this is not one application. This is green, it's a geometry stage. This is blue. It's a mechanical stage, Ansys Mechanical, and stage from 4 to 7. This one is blue, so all this one is blue. Additionally, we can say that on a stage of geometry, we can open different type of geometry editor in Ansys. It can be Design Modeler, it can be Ansys Space Claim, it can be Ansys Discovery, and they would like very different, but all this, it's one stage. Geometry. Okay, we return to this list, to this collection of objects, of solution objects, and this is our analysis system. And as we said previously, we have different collection list with different icons. For example, this one is coupled field. We will talk about it later. This one is structural mechanics. All components that are green from here and added here. And we don't have Ansys Motion here because it's separate application. We need to install it additionally to Ansys Workbench, and we need additional license to it. This all object came from A to Z, but we can do another way and we can create this different structure. For example, we have static calculations, we have quasi-dynamics or linear dynamics calculation, we have dynamics calculation, and we have additional one. We talk about it later. So what is static structural? Static structural, it's 90% of all calculations that do engineers, which must do some calculation with computational mechanics. A lot of them it's static structural. Most of them are linear with material behavior, and only some parts non-linear with contacts, and very few parts of all these static structural calculations are non-linear with non-linear material behavior. All this type of analysis, it's a static structural. Linear analysis, non-linear analysis, with linear contacts, with non-linear contacts, with linear materials, and so on. It's options of static structural analysis. Additionally, it can be calculated with only one step and with several steps. So it can be called as load cases, different load cases, or it can be called as quasi-static calculations, because we have changing of our loads in our cases, but we don't add some effects from dynamics, from transient tasks. So it's called quasi-static. Additionally, for static structural type of tasks, we can add eigenvalue. It's linear backlink, eigenvalue backlink, with Euler formulation, and it's a type of calculation for object that compressed, because if you try to tensile object, it would broke only with stress limits in most cases. If you compress this object, it can lose his forma, his topology, and lose his stiffness, and can break before you reach limits of strength in reason of backlink. So eigenvalue backlink is additional calculation for static structural, which can solve those type of analysis. It's a very simple analysis, and it's not accurate in all type of problems, but it's very useful in some cases. But you need to understand how it works. Additionally, based on static structural calculation, you can do structural or topology optimization. Some people called it generative design. It can be called in this manner, but more correct, it's structural or topology optimization. And in some previous version of Ansys, you can find two different objects: structural optimization and topology optimization. It's different type of calculation with different type of solver with different features and difference in name show those difference. Topology optimization, it's a more early variant of this application, of this type of calculation. So by analogy with quasi-static, it's not a dynamics, but it's not a static. It's closer to static, but with change in loads, we thus called as quasi-static. And if some tasks can be solved with static analysis, because they have some dynamic behavior, and it's very important, but we don't want to solve full transient analysis, we can solve simplified analysis which have some dynamics effects can show you. It's called in very different manner. Sometimes it doesn't called in any manner. It's called as type of analysis: model, harmonic, random, vibration, response spectrum. In some type of analysis application, in some type of CIE, you can find the name linear dynamics. I use quasi-dynamics terms for understanding those type of analysis. Model analysis will found the model frequencies and model forms. Some people say that it's just a moment. I sometimes have problem with English words. Some people say that it's a resonance frequency and resonance form, but it's not fully correct to use this term. It's model, its own frequencies of this construction, not resonance, because will it be resonance or it will not be resonance, we can know with those additional type of analysis. For example, harmonic response will check those constructions that have model calculations, check for resonance with some type of harmonic loads. We have some boundary condition, we have some loads. Those loads change in with frequency in some range, and we have a response, and we see does we have a resonance or not. A random vibration and response spectrum, it's more complex type of analysis. A random vibration is, for example, if you send some object, some detail, some device to space with the rocket, and this rocket flight, and it's vibrate during this flight, and those vibrations are random. You can use all vibrations from a set of different accelerometers, for example, but every flight will give a random vibration, random those graph from accelerometers and so on. So it's not very correct to try to solve transient task with those laws. It's more accurate to create analysis of these random vibrations to check in which frequencies we have what level of acceleration and which type of frequency we see more on this graph, on these accelerometers. And those type of information we apply to our construction, to our model analysis, and we see stresses, deformations in our construction, and we can see does we have problem with those construction, with those type of exploitation or not. This type of vibration can be found in many different type of tasks, not only for space tasks, but for earthquakes, for driving cars, and so on. And transient structural, it's more complex way to analyze your tasks and your device, because it gives a lot of time, because it solves step by step, and this step would be very small. And we also need to check not only stiffness of construction, but some inertial components. And this transient structural, also as static structural, can be with linear or non-linear behavior of materials, with linear or non-linear behavior of materials. And transient structural in linear behavior, it's complex task, but if we take into account some contacts, non-linear behavior of material, it means that transient structural became more and more difficult, more and more complex, and need more and more time to be solved and analyzed, because those steps by time need to be divided in some sub-step for creating non-linear solution. So if we solve static structural analysis and transient analysis in linear behavior, in only linear behavior, static structural would take 80% of time of transient structural if we use the same step of time. If we add nonlinearity, transient structural in most cases would be not 1.2 120% of static structural, but 10 and even 100 times more than static structural, especially linear. So, we can solve a lot of tasks with transient structural, but some of them we need to solve with rigid dynamics. If all objects that we use in our calculation, all parts, all solids, can be solved as rigid dynamics, rigid body dynamics. It can be solved in a more quick way than transient structural with finite element model with deformable objects. And we can obtain from rigid dynamics different accelerations, forces in joints, and so on. And we can apply it to some object, not to all mechanism, not to all machine, but for only part or number of part. And we can solve static or transient calculation, not for all assembly, but for some parts. And that will give a lot of benefits to us as an engineer, because we spend less time. In transient structural, we also can solve some object as rigid, but it has some benefits and some problem in comparison with rigid dynamic calculation. And the other type of calculation is explicit dynamics. If transient structural have step by time about couple of seconds, about 0.1 of second, or for example 0.001 of second, 1e minus 3 of second. Explicit dynamics is for much more complex type of calculation. It's for calculation with very high speed of process, with very short time of investigation, and with very big and complex type of non-linearities. So explicit dynamics use full time of investigation, which can be the same as one step of transient structural, and even less. We can solve process, for example, explosion, penetration of armor, deforming with press, and so on. And all this process can be 1 and e minus 3 for all this process. It ends after one step of transient structural. And for those type of calculation, you need 1e minus 5, 1e minus 7, 1e minus 13 of second for one step. So it's very complex type of tasks, and it can be it needs very big computer, it needs huge resources and a lot of time to solve those type of calculation. And you can solve it with Autodyne solver with explicit dynamics, or with LSDyna solver with LSDyna. LSDyna is more accurate, but more accurate needs seems more time and so on. So this is all calculation objects for structural mechanics. And we have additional object which appear in Ansys 2022 version. It's substructure generation. Sometimes we have very big and very complex assembly that we need to solve. Sometimes we have very huge mesh with a lot of mesh elements, with a lot of mesh nodes. And it needs very big resources. It needs very powerful computer with a lot of RAM. So there are one approach that can help us to solve these assemblies, these big meshes, with more adequate computer, which cost less. It's called substructure. We can divide our big task in a number of tasks which are connected on some place. For example, this our object and it connect here. So we can calculate this object with boundary conditions here and this object with boundary conditions here. And we can solve it separately. Additionally, we can use static structural for submodeling. We can solve this one with coarse mesh and then use result of coarse mesh for detailed modeling of this part of this cup, for example. And submodeling and substructuring are very good and very important way to solve our tasks. It have their own benefits and problems. And submodeling can be solved with static structural, and substructure needs another object. Here it is. So this is type of structural mechanics. There are a lot of talks that we need to talk about any type of this calculation, and we talk about this all object in other course when we talk about Ansys mechanical and when we talk about type of calculations in theory. So we became to other part, and other part is CFD. CFD it's computational fluid dynamics, air dynamics, hydrodynamics, soil dynamics, dynamics of discrete parts. All of this type of calculation can be called CFD, computational fluid dynamics. Even a lot of people, when they going through some corridor, when they going through some apartment with small doors and so on, work as a fluid. So, fluid dynamics, this is one. And this is A to Z names. And this is name which also present in Ansys, but I doesn't have licenses. And this is my object that have other structure which more accurate. So we have three type of CFD solver in Ansys. We have three different type of application. It's CFX, FEArytales, it's Fluent, and it's Polyflow. CFX and Fluent, it's browser, which have in some ways very similar possibilities. They use different mathematics. They have some different end features. Some people say that Fluent have more benefits and it's more powerful than CFX, but Ansys says that it's two different type of application CFD, and they have their own benefits. For example, Fluid Flow CFX have additional type of object for turbo machinery fluid flow. There are not only one type of calculation, type of object, but much more. I doesn't have license for them. So turbo machinery, it's a benefit of CFX. And for Fluent, one of the benefit is tensor mathematics that can help you to solve not only CFD tasks, but tasks from structural mechanics, from electromagnetics, and so on. And there are two types of object, fluid flow fluent and fluid flow with fluent meshing. This one start Ansys mechanical for creating mesh, and fluent for all other stages. This one start fluent meshing for meshing and fluent new interface for all other type, for setup, for result, and so on. Polyflow, it's very interesting type of analysis. Polyflow, it's very interesting type of application because it helps to solve some technological issues and problem with plastics. If you have blow molding process or extrusion or some other type of producing plastic parts, it can be solved with Polyflow. And we also have heterodynamic diffraction and heterodynamic response in its other type of analysis. It's something in between of heterodynamics and acoustics tasks, and we call about those type of tasks later. So there are also four type of analysis, 3 or 4 depending on how to solve, and we structured in one slide which we called others. So we have two thermal objects, steady state objects and transient objects. It's only for structural mechanics, and in most cases it's not for changing type of object, type of fast changing. So we can solve changing of phase, but with APDL scripts and additional information, with a lot of different efforts, and much better to use, for example, Fluent for this type of tasks. This is for mechanics, and steady state it's for static calculation. Transient it's for dynamic calculation, and those calculation can send the result to, for example, static structural or transient structural tasks. Also, we have electromagnetic tasks. This is object for that. And we have some object for task in between. When we have couplet field analysis, where we have electric some physics and thermal physics, and those physics can be solved separately because they give a lot of problem. And we have harmonic acoustics, model acoustic and static acoustic. It's a different calculation with acoustics. We would talk about this later. Not today. But if you need an acoustic calculation, different type, for example, you need a static calculation with acoustic materials. For example, you need some tank which have which filled with water, for example. You can use static acoustic for calculate effect from water to model and form, for example. And you can solve some acoustic type of calculation for rooms, for noise, vibration, and so on, with these two objects. So, and the last one, it's couplet field. Couplet field harmonic, model static, and transient. It's something like that. It's for acoustic problem. But for more complex tasks, when we have fluid and structure, and both of them not only connected, but apply one to each other and change their behavior. So couplet field is for those type of calculation. So I hope it was interesting. If you have question, write below. If you want to see some example of different type of calculation, please write. Maybe I can show how this task can be solved. Also, give a like to this video, share it, write a comment and question if you have, and become a patron if you want to see much more information about Ansys or other computer-aided engineering software. Bye.